Okay, so just a quick few words about myself. My name is Anton. I'm a Python developer. I do consulting on kind of like Python development, machine learning, AI in general, and I am a co-founder of this group. We've been doing this for about 6 years now almost. We stopped for a while throughout the pandemic, and then we restarted a few months back, and we're back to our kind of like twice a month schedule, where we meet the first Thursday of the month and then the third Thursday of the month. So we've just because of the whole pandemic, people moved away a little bit, and we decided that it's a lot easier to actually do these meetups and events online. So right now, this is the current format for the meetups, and that's not to say that we will not restart some of the in-person events sometime, maybe later this year or next year. But yeah, that's pretty much about me and about the kind of like meetup in general. So for tonight, I wanted to go through a quick presentation on how to do Q&A over a large set of documents. This is kind of like the research and basically everything was done for a client, but I cannot show the documents that they've used, so I had to come up with something else. So principle is the same, hence I just kind of chose Marcus Aurelius. I looked online for different subjects, and I found on the Gutenberg project 4 different books that had information about Marcus Aurelius. Marcus Aurelius, it's a Roman philosopher and emperor that lived about, I don't know, 1st century AD. So that's kind of like all I needed was a large amount of text data. So what I ended up doing, I ended up finding these books. One of them is The Thoughts of the Emperor Marcus Aurelius Antoninus, and it's about 140 pages. This other one, it's a letter from Celsus to Lucian. So it's a letter about an evening that Celsus had with Marcus Aurelius and his family. This other one is quite a big book. It's about 530 pages. So Roman Society from Nero to Marcus Aurelius. And then this last one, it's actually a book written by Marcus Aurelius. It's called The Meditations of Marcus Aurelius. So total, we're looking at about 750 pages of text that we can actually start going through and searching. So my client basically needed this for due diligence. They would have to work with projects that would send them a lot of information, and they had to actually be able to really quickly assess and figure out where chunks of the information are, right? And it seems to be quite a hard thing to do with a regular text search, right? So if you're looking for a certain phrase or a certain kind of set of words or a sentence, your chances of finding that in a large corpus of text with a regular keyword search are pretty much zero, right? Unless you know the exact keyword that you're looking for, and then at that point in time, let's say you look for just one keyword, you'll end up having tens or even hundreds of places in those documents where that keyword was used, right? So through AI and through vector databases right now, we have the ability to very easily do semantic search. Semantic search is basically the ability to take a sentence and use that sentence, extract its meaning, and then look through the text, through the big corpus of text for similar paragraphs or chunks of text that have a meaning that's very kind of close to it. So we've done before presentation of vector databases. So we have our YouTube channel, and on that channel you can find these presentations if you guys want to look for them. Just go on YouTube and search for SIG-AI and they should pop up. And again, tonight's presentation, it's going to end up in there as well, probably early next week. But kind of like back to this. So in order to do the similarity search or the semantic search, all you have to do is to extract the meaning of a chunk of text, and that's done through embeddings. So this app, in order to work, needs to take a large corpus of text, split it in chunks that are kind of like, you can adjust however big of a chunk do you want. Here I went for about 1,000 words, where you can take a chunk of 1,000 words and you can take a few of these and pass them through OpenAI for just kind of like to use as a context, right? So basically took the large corpus of text, splitting it into these chunks, generated embeddings for each one of these chunks, and then by using a vector database, you can actually do a similarity search on that, in where you take your question, run it through an OpenAI to get an embedding, and then you do a similarity, or kind of like a cosine similarity on that question that you had, and find out the top, however many do you want, chunks in the database that are closest in similarity to it, right? Then you take those chunks and put them into context together with your question and send them through API to GPT-4, and that's going to give you the response that you're looking for, right? It sounds very complex. It sounds like a lot of work, but in reality, if you look here, we're looking at however many lines of code this is, right? So it's a very simple process, and that's due to LangChain. LangChain is this library that basically they've taken all these low-level stuff and converted into high-level, right? And so that makes it super easy. So what we're gonna build tonight is basically an app like this, where we have a quick interface that right now would allow us to type a question here, and it would go through all this text and figure it out what the answer would be, and it also would return to us the list of kind of like chunks that have the highest kind of cosine distance to, so cosine similarity to your original question. So let's just kind of try one very simple one. When did Marcus when was Marcus Aurelius born? So it's a very simple question. And what's happening right now, this has been converted to, or actually it's a little bit more that's happening. Right now you see we don't have a database folder, and it just showed up. I'll explain that when we get to the full text, and that's why to the code for this app. And that's basically has generated the whole database of it, of embeddings, and that's why it took so long. And yes, he was born on the 26th of April, 2011, and the sources are this, the Thoughts of the Emperor of Marcus Aurelius PDF on page 0. So, and it starts exactly with that, right? And you have an option to have kind of like as many responses as you want. So we'll look at that. And each one of these answers might have or might not have the answer, or might have some chunks of the answer, and that's depending on the similarity with the stuff in the database. Right. So it's a very simple process in the end. So to get started, you see here LangChain. Let me zoom in a little bit. LangChain is the model that deals with everything. Here we have a directory loader. Then they have an interface for OpenAI, which, by the way, by choosing the LLM that you want to work with, I mean, it doesn't have to be OpenAI. It can be anything. You can use Cohere, you can use a locally hosted model, you can use Llama 2, any model that LangChain has an interface for, you can use it. Or if you want, you can actually write all this code kind of like the regular way and deal straight with those models and those endpoints directly, right? So here we have the embeddings endpoint, the OpenAI embeddings, the Chroma database. So we're going to use Chroma for this. Chroma, if you're not familiar with, it's a vector database that's pretty much running locally and is as simple as SQLite, if you're familiar with that. It's almost like a file database. It's just everything is stored in here in this database folder, and you can have access to it. And it's quite amazing for applications like this, right? So that's the Chroma, and then so I'm doubling up on embeddings. Okay, then the chat OpenAI and the retrieval QA are the parts that are dealing with talking with OpenAI to get the answers back, right? So first thing, I'm just kind of like setting up. Sorry.
What other chat models does LangChain support?
Well, through OpenAI, I'm not sure. I think they're allowing Cohere, but I'm not sure if they made it as a chat as well. So I'll have to look into that. And by the way, they've just revamped their whole documentation and the whole website. And good luck finding anything on it anymore.
Oh, gee.
Exactly. I've been through it this afternoon. I was trying to find some information and I could not. And I mean, that's information that I knew it was there. So I guess at this point in time, they are just revamping everything. Probably they're going to have to do, they're relinking back, because none of their links to other parts of the documentation seem to work. So I was having a lot of issues, right? So, but the chat OpenAI, it's required by retrieval QA, and it's kind of like running behind the scenes. And then a retrieval QA, it's just this higher level class that deals with the whole taking of a question, converting to an embedding, doing the search in the database, taking the answers from the database with your question, sending them to OpenAI, and get the answer back. So everything, all that stuff that's kind of sounds really complex is not just in one call through this retrieval QA, right? That's why this code is so simple. So here, I'm just kind of setting up my variables. I set up an OpenAI API key, if I could speak. And I set it up as an environment, so it has access. So basically, LangChain has access to it. Then set up my sources directory where the PDF files are, and then the persist directory is where the database is going to get stored. The Chroma database is going to get stored, right? So if we go through this, kind of like one by one. this next operation here, it's the loader. This PyPDF directory loader is kind of higher level class that allows you to pass a directory. They would go through, take all the PDF, split them into chunks, and then prep them up for loading into this docs, right? And so the moment you load it to docs. So right now, if you see, all those PDFs have been converted into these 745 docs, and each and every one of those docs has about 1,000 words. They also have like a page content, which would be still here basically. So that's the page content. They also have a metadata where you have the source and the page. So it automatically builds that one for you, which is quite awesome, because when you need it, it will show up in here, right? It's very easy to figure out exactly what document and what page this one is coming from. So now, depending on your needs, you can adjust the size of this chunk, right? So you can reduce it to a few hundred words, or you can just kind of go even more. There are ways of dealing with the whole document as a one piece. The only drawback with doing it that way is that you will use a ton of kind of like API calls, and that you pay for, because OpenAI is not necessarily free. When doing that, every call you would have to send all of these 700 pages to be searched through and figure it out. Hey, is my question close to this chunk, to this chunk, to this chunk, right? So that's why this vector database is coming into play. They're helping you just choose only the chunks in the big corpus that are as close as possible to your question, right? So this was the first step where we generated the documents, and now with those documents we can actually, just by calling embedding and OpenAI embeddings, and then calling this vector DB, where we create the whole Chroma database from documents. We pass the documents, we pass the embedding function, and we pass the directory where it needs to be stored. So when we do that, basically it takes all those documents, goes to the OpenAI embeddings API endpoint, gets an embedding for it, and stores it into the database. So does that for all these 745 chunks. And again, this is just basically 2 lines of text. And this last one, the persist, you can work with ChromaDB 2 ways. One, you can work with it in memory. So if you want to just do something really quickly where you have these for the session, and then once your program stops, that thing evaporates, or you can actually store it on the hard drive. When you run a full script, it will automatically do the persist, but within Jupyter Notebook, I don't know exactly why, you have to call it, otherwise it just keeps it in memory. So that's the reason it's there. So basically, right now, if we run this, it's going to go through all those 745 kind of chunks of text. It's going to overwrite, or actually it's going to double up. It's going to double up my directory here right now. So yeah, so you see, it takes about 15, 16 seconds to do this. And then this one was about another 15 seconds to take all the PDFs and chats. So this you would run it the first time, and this is what's happening here when we ran it for the first time. That's why it took so long to come back with the first answer, right? So basically, this would kind of generate everything, store in the vector database. So right now we're ready to do the second chunk, which is querying the corpus, right? So again, setting up my variables where model name is the model that we want to use for the application. I chose GPT-4. You can use GPT 3.5 as well. Depends on how accurate you want your answers. So GPT-4, I think it was about 30 times more expensive, but throughout, yes, but what I wanted to say is that I ran this probably 4 or 5 times today, and I think I paid $1.50. So it's still minute in the whole scheme of things. So, and especially that I've been running it on and off just to kind of test, make sure the presentation runs fine. When you do it for an application or something, you just run it once, store the database, and just kind of move on, right? So you don't necessarily need to go through a lot. And I mean, to pay about $1 for 700 pages is not that bad, right? So again, and now this K, it's the number of answers that we get from the database, which it's basically here, right? So when you do this similarity search, you're basically saying that you want a certain amount of answers back. In here, you'll see that we have 1, 2, 3, 4, and 5. I just wanted 5 to make sure I get a better answer. And there are multiple ways of doing this. This is a simple similarity search. There is another type of search where they are choosing kind of like both similar, but also opposites to try to give you a more kind of like well-rounded answer. So I haven't played with that much, but that's just kind of like there for you guys to know about it if you want to play with it.
Nice.
So yeah, again, if you guys have any questions, interrupt at any time. That's the perfect time to actually ask a question when we're talking about it rather than at the end. So
Anton, this is Raman.
yes,
I have a question.
yes.
So whatever you did prior to this is essentially reading the documents and creating a vector database, right?
Yes, that's all. That's all this was. Basically, here we read all the PDFs, chunked them, and then for each chunk, we've created an embedding and stored that embedding and the chunk in this vector database.
And the
So
reason you chunk is
because the models have certain context length, right? So I think OpenAI has like the GPT-3, I think it's 4K, so 4,000 tokens that it's allowing you to have maximum. Then like GPT-4, I think it's 8,000. They have another model that's about 32,000 where this chunking is not as necessary. But so that's one of the reasons, because of model context length, right? That's one of the reasons that you chunk it. And the other reason is cost, right? So now think of it this way. If you run this model one time and you send this, let's say, instead of having just 1,000 tokens, you work with the 30,000 tokens model. So let's say you have 20,000 tokens that you send once, right? That big chunk of text, every time you send it, it counts as tokens input, and they're charging you for. So the smaller your input is, the less you pay. Especially, I mean, if you run it once or twice a day, not a problem. But if you run it 100 times a day, 200 times a day, where you have a ton of people doing research over this document, or you have your whole company's knowledge base where people do this on a continuous basis, then you want to minimize the amount of data that gets sent to OpenAI and back, because you don't want to pay for it. And especially think of it also from the standpoint of a chat model, right? With a chat model, every question gets added to the history of the chat, right? Because the model doesn't actually have a way to remember that you asked me 2 seconds ago about this, right? So the chat model works by, hey, I'm sending you this answer, you sending me back, I'm sorry, I'm sending you this question, you're sending me back an answer. Now, I want to ask you another question. Well, that other question gets added to that set of messages that you started with. And every answer and every question keeps on being added to it, right? So if you keep on adding to that, first, you'll, even with the 32K model, context model, you'll run out of context very soon if you have this large amount of text that keep on building up. And also you'll pay for them every time, right?
Got it. Got it.
So
So
that's
my
kind of
question,
yes.
I got the logistics part and the cost part. My question is coming to you more from how you chunk it. You have different options of chunking it.
Yes.
How you chunk it, does it still, irrespective of how you chunk it, will it still create the same embedded database, vector database, or will it change?
So there are multiple ways of chunking, right? You can just go and pretty much take it on certain amount of characters, cut it right there, go to the next chunk of characters, cut it right there, next, right? The other ones where you're doing it by tokens, where it kind of, you set a certain amount of tokens. Tokens are like a part of a word, right? So they're not the full word. It's almost like, I don't even know exactly how. It's just like roughly about 3 to 4 letters each. So it's a model that worked pretty well with this model. It's a way of representing the data in a way that worked really well with this model. So that's why we're kind of using the tokenization. And so you can use tokens and do the same exact thing. Then the other thing is, if you want to be more precise, you can go by sentences and make sure that you have full sentences within this token. You don't cut it, right? Mm-hmm. Another way that there's another way of tokenizing it is just overlap. So you have a chunk of 1,000 tokens, you can overlap 100. So the next chunk has that overlap. So there is some sort of a continuity between the pieces. I haven't seen much of a difference, and sincerely, I just didn't pay much attention to it. I used what's default, and the default is basically splitting into 1,000 tokens and doesn't really care much about how it's cut, no overlap, no nothing. So that was my experience, you know.
Okay. Thank you.
So yeah, I mean, might kind of like make sense in certain application. Maybe might make sense when you have, like, rather than 1,000 tokens, maybe you have 100 or 200 tokens. Then you might split that meaning over a few of them. So it might be worth to have overlaps, but I haven't really played much with it or did research on it. So I'm just kind of like thinking right now how that might work. But just kind of like with this 1,000 tokens worked pretty darn well.
So where I'm coming from, Anton, is that we have many words, tokens, which are exactly the same, except that the context in which you use it, it has entirely different meaning. Right. So I'm kind of wondering, you know, our chunking, does it create the context? Let's say you're chunking, 1,000 tokens, and then you have the same word used in 2 different contexts. Will it recognize it? Will it, create 2 different, embeddings, or will it create the same embedding? Is what I was trying to kind of mentally visualize. Okay, you don't need to, get into that. It's probably
so. I'm pretty sure that it would create a slightly different embedding, and the embedding, it's more it's figuring out the context of everything rather than just the word, right? So when it does that, I would assume that, I mean, the embeddings for OpenAI are like 1,500 characters, I mean, 1,500 numbers long, right? So that's just kind of like, it's a lot. And because of that, it's really easy to find context that's very close to one another and figure out nuances within the use of that context. So, and I would assume that when you have an overlap between the chunks, you might have them getting closer to one another, right? Versus when they're strictly cut separately, there is no necessarily continuity between the two of them as much, right? So if you think of a paragraph, a longer paragraph, a very long paragraph, then if you cut it in two, even though both sides speak about the same, it's the same idea spread throughout those two chunks, I would assume that it would still find some dissimilarities, and still you'd have two vectors that are not perfectly one on top of the other, but are a little bit spread out, you know?
Okay, got it.
So,
thank you.
Yeah, I'm just kind of like, that's what I'm thinking. But I haven't really done any research or anything. And the models have been this model that's the OpenAI embeddings, I forgot its name right now. It's working pretty well. I think it's kind of like the best one out there. I've tried Cohere, and Cohere didn't give me as good as results as OpenAI did for these embeddings. Cohere is beneficial when you're dealing with kind of like smaller models, or you want to run through this a lot faster because their vector sizes are half the size of the OpenAI. In the same time, the quality is not as good as OpenAI's. So, and there was at one point in time, Cohere turned out to be a lot cheaper than OpenAI was, but a month or so ago, OpenAI just dropped their price and pretty much made the same, make it similar to Cohere. So there is no reason not to use OpenAI for this, right? So, okay, back to this. So here I have the corpus. I just want one result for now, and I am setting up the LLM to be used. It's the OpenAI, and I pass the model name, which is GPT-4, temperature 0.1. So I want it to be as precise as possible. And this verbose true, it's just kind of for the backend to print out what's happening, so it doesn't affect the model in any way, shape, or form. Again, this one I put it here just because it's used again in the embedding. So it's been defined earlier above somewhere. Yes, it was defined here, but I just did it again, like to keep these two chunks of the code working, finds independent of one another. So this would be the embedding, and then here it would create this vector DB. Now, once I have this vector DB, you can run on it a similarity search, right? So if I run it directly, let me make sure that everything else is run. Right. So this is what I'm saying, that everything is moving along so fast with LangChain that right now is it's basically stuff gets deprecated so quickly. So that's why I used the from LangChain chat models import chat on OpenAI, but it still didn't do it. So probably what I have to do, I need to upgrade to the latest version of LangChain. But this is just a warning, and it still works, so the code is fine. And here, basically, all I'm doing the similarity search in the vector database. I'm not talking yet to OpenAI. So here, you see how it returns this document, page contents, and then I have the metadata coming back from the database. So this is quite awesome because now I can take this and pass it to OpenAI. There is another option. You can do it here, just similarity search directly, or you can say similarity search with score. So that score, it's that metric that I was telling you earlier, that it's basically the cosine similarity between the question, here, what was Marcus Aurelius' real name, and this document is this 0.33. And actually, this is, they're using the cosine distance rather than cosine similarity. So lower it's better, right? The distance, so the shorter the distance, the closer you are, right? The cosine similarity, it's kind of like the closer to one you are, the better for both of them. So that's just a simple way of dealing with the database. And then if you want to introduce OpenAI's API, you create this retriever, which is basically an interface that's kind of like returning what you want based on your query, right? So this is the retriever part that's getting the data from the database. And then the retrieval QA combines the retriever and a question and answer model in LangChain to basically get your answer by running it through the database first and then sending it to OpenAI and get the answer back. Now here, if you look at the chain, there are multiple ways of dealing with this. This chain type stuff means that you're just sending all the text, right? There are different ways, and I can go into this towards the end of the presentation if you guys want to learn more about it. This is what I was saying in the beginning, that you can send the document, the full document, and have OpenAI read and chunk everything, but that's going to be extremely costly if you run it over and over and over, right? So this is basically setting it all up, and now I'm running the query, and right now got the similar answers from the database, send them to OpenAI, and then it returned this whole chunk of text. So it says, yes, he was very punctual, and this is part of that Marcus Aurelius' Lanuvium, the letter from Celsius to Lucian, and this is basically exactly what he was described in that letter. So it works quite well. So that's why kind of like this is like a generic way of kind of like explaining you how everything works in there. Now let's look at the—
So Anton, before you move on, a quick question.
Yes.
So you have a query. You
Yes.
demonstrated multiple queries about Marcus Aurelius.
Yes.
And you went and called the ChromaDB
Yes.
vector database, and you got the answer.
Right.
So now why are you going to OpenAI?
So that's why I was kind of like showing, yes, you can do this, but then my question to the vector database is, what was Marcus Aurelius' real name? The answer is this chunk of text. So if you want to spend the time to look through this text and figure it out from here, that's totally fine. It's totally up to you. But if you want the actual answer, like here, Marcus Aurelius was born on the 26th of April, that's kind of like you would need to go through OpenAI.
So you are not quizzing OpenAI for the answer. You're just essentially telling OpenAI, look at this and sort it out for me. Okay.
Right. So let's put another name here. Let's I don't know, Shaquille O'Neal. It should return that He doesn't know because it's not part of this. And in the back end, what's it called? In the back end, LangChain, part of the prompts that it sends with this whole thing, part of these prompts that are sent to OpenAI are specifically telling it to use only information from these documents and return I don't know otherwise. That's to
Got it.
reduce
I got it.
any
Okay.
kind of input
So
from
it's
the
just
outside.
simplifying the whole exercise of simplifying the response is what OpenAI is doing. It's not
Yes.
querying
So
the. Okay, got it.
right. So OpenAI, all it does is giving you a nice answer, like here. That's it. You know, it's not doing anything, right? Because here, in none of these documents, it says that Marcus Aurelius is related to Nero, right? But it figured out that Nero was a member of the Julio-Claudian dynasty, while Marcus Aurelius wrote for Nerva-Antonine dynasty, right? And they were a few hundred years apart, so they are not related or anything, right? So it was able to do that. Otherwise, you'd have kind of had to go through all these chunks of text and based on that to come up with the same conclusion yourself. You know, that's the beauty of OpenAI. It's able to analyze the text for you based on what's in there and come up with a nicer, cleaner, formatted answer.
So what is it that Cohere doesn't do as well, or does better?
Embeddings. The one that I was working on were the embeddings. So extracting the meaning of a chunk of text into a vector, right? So they were, I don't know, they were not as related as I was kind of like expecting them to be, and kind of like wasn't too happy about it when I tried.
Okay.
So yeah. So yeah, so OpenAI is there just to be able to give you a nice, clean answer at the end. That's all there is.
So
right?
when you wrote out a question, you know, when was somebody born? It's not that you're doing a similarity search with the you know, vector database. It's not that you are, you know, running a query against the vector database. You're just looking for something similar.
Yes. So in the end, I am running a query towards the database, but it's different than like it's into a regular SQL query.
Gotcha.
In the sense of when I have this sentence, right? How does Nero compare to Marcus Aurelius? LangChain goes and to OpenAI, to the embeddings API, and comes back with a vector embedding of this, right?
Okay.
And now that vector embedding is sent to the ChromaDB to do a similarity search, to do a cosine distance search, right? Between this vector and all the vectors that are in the database. And based on that, we get the top 5 answers. So we get the top 5 vectors that are close to our questions vector. Make sense?
Yeah.
Okay. So then once we get those 5, we also get the text back, and we use that text back to send to OpenAI to give us this nice, clean
Buddy, you have to get that
answer, you know?
Okay. So in this context, Anton, I remember you saying that you can persist the database. You could, you know, create a vector database once and for all and have it on your laptop or wherever.
Exactly.
Right? Now, let's say I persist it using OpenAI embeddings. And you know, I want to run it against Cohere.
You'll have to do the same exact thing, but using Cohere.
So I just wanted to clarify that. Okay. got it.
Yeah.
Okay,
You're
so
not going to be able to say this vector from OpenAI matches with this vector from Cohere. They're completely different. First of all, the dimensions. I mean, the dimensions of OpenAI are double than the ones from Cohere, right? And the
right.
models that have generated for OpenAI, the model, the AGI model, it's completely different than the one from that Cohere has. So each model has its own understanding of what the meaning of that chunk of text is, right? Or the representation of that meaning is different between the two models.
Got it.
Right.
I wanted to be sure of that. Thank you.
Yeah, it's almost, I mean, the easiest thing for me to think of was one would be in Chinese and the other one would be in English. They would all have the same meaning and the same content, basically, or yes, meaning rather than content. But one is in Chinese, one is in English. If you don't know both languages, you don't know how to translate, right? So these two models are two completely different models that are not going to be able to talk to one another. So, make sense?
Yeah. Thank
okay. Anytime. So yeah, so what I wanted to show kind of in the end is basically the code for the app, which again, it's, if you look at this whole thing, it's like 70 lines of code. It's nothing major, very easy to kind of like generate. And we've pretty much went through everything in here. Here is just formatted different to be able to run it in, as a script, right? So again, the imports, we're using Streamlit for the UI. It's very easy and nice to work with. The same thing, the same LangChain imports. Then variable definitions here, where we're having the API key, the persist directory, sources directory, the model that we want to use, and the embedding model. Right here, we're specifying it. So here you would use, if you want to use Cohere, you would use their model and their embeddings model. You can switch that one, and everything switches to Cohere. And that will be just working as fine, right? And the K for this, for the application, the number of answers that I want back from the database, I just set it up as 5. And again, I create the models, the embeddings model and the LLM model to be used. And here, this is the embedded store. So I put it all into a function to just kind of load the document, create the vector DB, save everything into it, and just close it. So right now, I'm just running that function, passing the embedding model, and passing the directory that I wanted to be created. So that's exactly what happened when we ran it for the first time, because the persist directory was not present in that folder. Then once everything is done, just reload the database, create the retriever, and then do the retrieval QA kind of like part, and then basically this is the UI. We have a header, I just called it QA. Then we have the title, all about Marcus Aurelius, and then just generated this prompt area. And this is part of kind of like a backend. To run this application, you just kind of run it from the command line. You start it by using Streamlit run, and you pass the application. And so that print is just kind of printing here to console. And to just kind of keep an eye on everything. And then here, it's basically when I get an answer back, I just kind of clean it up and just kind of write down all the sources and the metadata and the page content, basically, to generate all this. And that's pretty much it. That's a very straightforward application. So LangChain makes it super easy to do it. Otherwise, originally when I built this, it was way, way, way more than this. It's I was actually building all the stuff kind of like straight in Python and dealing with the OpenAI API directly and all these things. So yeah, LangChain made it super easy to do it. So what do you guys think?
Well, it'll be interesting when we get more of a competitive world that has more things that will do this better. That would be my first thought.
Yeah, it's getting there. It's moving so fast. I mean, when was it? Last week or not even 2 weeks ago, the Llama 2 came out. And the Llama 2 model is almost on par with GPT GPT 3.5. It's funny because a friend of mine was doing some research and he's like, hey, can you ask GPT-4 what it thinks about this? And I was kind of playing with it and I'm like, okay, let me try Llama 2 as well. And I basically took both answers, sent them to him, and he's like, wow, the one from Llama 2, it's actually more on point to what he was looking for than the ChatGPT one.
Is it LAMA 2? I'm sorry.
LLAMA 2.
2, okay.
Yeah, so that's the Llama 2. The only problem with Llama 2 right now is that you need, I think it needs like 50 gigs of RAM, of V-Ray RAM. The V-Ray, my God, video card RAM, VRAM.
Oh, okay.
So you need quite a heavy GPU. So what I've been seeing lately is that they started to have on demand like a Lambda model for GPUs, where you're paying just for what you're using, which is quite awesome. I've seen a couple of services that came up with this. So that's going to make it a lot easier to use these heavy models on powerful hardware without having to pay thousands and thousands of dollars a month.
Right.
So,
yeah. Interesting.
Yeah. So yeah, especially that a lot of people do not want to use OpenAI just because of the whole, oh, they're going to use my data to train their models, right?
Yeah.
And that data is becoming public data. It's been all around the news. So they said that they've discontinued that process where any API call is your API call. They do not store anything. They do not save any of the questions or answers. So, but that's what they're saying. Who knows? But yeah, so that's why a lot of people are looking into using models that are running locally. So, and with that Llama 2 being closer and closer in quality with what OpenAI has, I think by the end of the year, we'll see quite a shift where open source is going to start to move ahead of these closed source ones. But for now, still OpenAI, the GPT-4, it's the best model. And if you don't have any privacy issues with the data that you're sharing with, then it's probably the best option and the cheapest option to use. So
it doesn't sound very expensive at the moment. I mean, it costs more to drive up the Nimitz freeway than to do that. So
right. No, it's pretty doable. It's pretty doable, especially if you. I mean, the moment you start using it a lot, it starts adding up. But now you have to look at also the time that, for example, if these documents were like, and I'm not saying that it's going to be the best answer ever, because sometimes it's actually coming up with some answer that you're like, why? It doesn't have anything to do with it. But for example, if you have like in a trial discovery over, I don't know, tens of thousands of pages, right? just the ability for that person to be able to just go through and find, hey, this information can be found at this page in this document, and this page in this document, and this page in this document, is quite amazing. So another one yesterday, actually, I had about 500 different documents that I had to parse through for specific information. And I'm like, okay, I can try to read the regex on this, and I'm gonna just kind of pull my hair out. Not that I have much left, but I'm like, what can I do? So I'm like, let's try GPT-4. Wrote a quick function, now that they have the ability to do function calling, wrote a quick function, sent each and every one of those documents and got the stuff back, and it was like 99% correct. Yes, I had to go and kind of verify a few things, but I was able to spend like less than $1 and wrote, probably it took me half an hour to write that code. And I got the stuff back, and then another half an hour to verify everything. I was done with it. You know? So it makes a lot of sense to use it for a lot of things like this, where you have unstructured documents and try to find chunks in it. So yeah, I really like the possibilities.
Thank you for explaining all of that. It's really incredible.
No, anytime. That's why we're here. That's why we're here.